Verzeo, your one-stop solution to everything learning.
Yep, good evening, one and all, and you're here for the second episode of Manvi Tyagis that is on recursion. And yep, I believe you had worked on the previous assignments that has been given by the mentor. Without wasting much time, I believe you have already attended the previous session. If it is a new session for you, then I would highly recommend to go ahead watch the previous video that we have already posted in YouTube. And yep, that's all from my end. I would be handing it over to Manvi, and you will be hearing it from Manvi. And yep, that's all, guys. If you have anything to ask, then just let me know.
Hello everyone. Okay, let's just start. Then let me know once you can see my screen. All right, can you all see my screen? Okay. All right. So just for me to understand who all so that I can proceed accordingly. Who all are there who are attending the session for the first time? Because I can see a lot of repeated faces as I remember from the previous session. So I'm assuming most of them are repeated ones, but some of them are new as well. Okay. All right. So those who joined new, do you have a base on recursion or are you completely new to it? You don't have a base, as Kamboji said. And for the previous, okay, that is for the new audience. They are new to recursion and they won't understand if if we just directly hop into questions. Okay, so as far as the previous session students are concerned, how many of you completed the assignment? Rohit is from the previous workshop. So I see not a lot of people have completed the assignment as well. All right. So guys, recursion is a topic that will require a lot of practice and will require a lot of imagination and paperwork as well, right? So don't take it as lightly as you've taken the other, if you might have taken the other topics. Okay, so yes, Prajakta, the recording is already on YouTube, but no worries. Let's try to work out for both the people. So what I'm gonna do today is I'm gonna continue from where we left last time, right? Instead of, we will not be solving very advanced problems. So there is no need to worry. Even if you are joining the session for the first time, you will understand it. And no worries as well if you did not solve the assignment, but to solve the assignment, which I will give today at the end of the session. I will not repeat the theory today, which we discussed last time. Okay. But for a quick revision before I hop into the questions, what is recursion? Recursion means when a function calls itself in the same function, it's called as recursion, right? And last time we did it all. This PPT is not for this time. We had it. We explained it last time. Okay. So from the last time we discussed that there is one defined way that can help you solve a lot of problems in recursion. That there are 3 steps in which you can think of the problem. You have to identify the smaller problem, like the problem that has been given to you. Identify a smaller version of it that can be solved. Then do some work by yourself, a step like in which, if you remember, all those who are from the last class, you would calculate a small answer, which is the first step. Smaller problem, let recursion do the work, which also includes finding the recurrence relation, if I speak in technical terms. Do your work was finding the final answer, if you remember from the last class, like doing something with the small answer and finding the final answer and identifying the base case, right? All right, so I'm sure the people who attended the last class will understand each and every bit of today's session, but I will try to simplify it for others who have attended it for the who are attending for the first time as well. Okay. And last time, because we had to cover theory as well, so I could not draw a lot of stack diagrams and a lot of people had confusion about like how this magic is happening. So today we will try to do a lot of stack diagrams. We'll do a lot of dry running and understand each and every problem to the depths of it. No, Ganji, this class is not about machine learning. We are discussing recursion today and we'll be solving some problems on recursion. Okay, all right. So last time we did these 2 questions, count of digits and sum of digits. So we'll be continuing from there only today. Count of digits and sum of digits. I hope last time these were clear. Now I'll start from a new question, nth Fibonacci. So what is a Fibonacci series? First of all, let's start from there. Does anyone of you already know what is a Fibonacci series? So let's do one thing. let's not write code in any language at all. Let's write pseudocode so that there is no issue of language. All right. So I will be writing language independent code today. I'll try to write language independent code today. Because I see some people are saying write in Python, some are saying write in C++ or C. So let's do one thing. Let's write pseudocode. Let's understand the logic, and whatever language you write code in, go from the session and write your code yourself. Okay. So Fibonacci series looks something like this. It starts from 0 and the first two numbers are 0 and 1. This is the first Fibonacci number and this is the second Fibonacci number. Third Fibonacci number has to be the sum of two previous numbers. So third Fibonacci number is 0 plus 1, which is again 1. Fourth Fibonacci number is sum of third and second Fibonacci number, which is fifth Fibonacci number, which would be sum of 3 and 4. So fifth is basically 3 plus 4. Fourth is basically third plus second, right? So fifth will be 3. Similarly, if I keep writing it, so I will have a series like that. All right. So this is the question. Like this is what Fibonacci series means, right? I'm glad a lot of people have little bit idea and fair idea as well. So let's come to the question now. The questions in the question you will be given n. N will represent which Fibonacci number we want to find. We don't want to print the series. You will be given a number n. The query would look like this. N is, let's say, 5. So you want to find the fifth Fibonacci number, and fifth Fibonacci number is 3. All right. Or we can consider this as the 0th Fibonacci number as well. If I consider it as like it's dependent upon the indexing. If I consider it as 0, this is second, then this fifth Fibonacci number in that case will be 5. All right. I hope there are no doubts in the definition of Fibonacci. Now let's try to see to find the nth Fibonacci number, right? To find nth Fibonacci number, what do I need to know? I need to know what is the n minus 1th Fibonacci number, right? And what is the n minus 2th Fibonacci number? I hope that's clear, right? Because we have to add these two, right? And to find n minus 1th Fibonacci number, what do you need to do? You need to know the previous two numbers, which is n minus 2th Fibonacci number or n minus 3th Fibonacci. The sum of these two will make that. For n minus 2, you will need n minus 3 and n minus 4. Similarly, for n minus 3, let's say, you will need n minus 4 and n minus 5. Any doubts until now? Dragan, Ajay will send you the link of the first YouTube video. Right. So now clearly we can see one thing that you see we have already found the first step of the problem. The first step was to find the smaller problem. So this is the big problem, and to solve this big problem, we need to find this small answer and this small answer, right? So we know this is the bigger problem, and the smaller problem that we need to solve is finding nth minus 1 and n minus 2th Fibonacci number. So the first step of small work is done. And what is that step? That nth Fibonacci number will be equal to n minus 1th Fibonacci number and f of n minus 2 Fibonacci number. What do I need to do? I need to add here. I need an addition operation here. Right? Second work was your work. We have already found out what our work is. Our work is doing the addition. We did it here only. Third is base case. Base case, what is base case? The smallest problem for which you know the answer. Now please tell me in the chat, what is the smallest problem? What is the smallest value of n for which you definitely know the answer? Like if I say n is 0, do you know the answer of n equal to 0? N equal to 0, let's do 0 based indexing itself, right? For n equal to 0, right? And for what is the answer for n equal to 1? 1, right? So if n equal to 0 or n equal to 1, then I know for sure that my answer is gonna be n itself. For 0, it's 0. For 1, it's 1. You could have written it in two different statements as well, but you could definitely write it simply like that also. So let's take an example. I need the Fibonacci, let's say n is 5. Okay, so for 5, I need to know the fourth Fibonacci number and the third Fibonacci number. For fourth, third and second. For third, second and first. For third, again, second and first. Second, first and 0. Second, first and 0. Should we make the call for 0 first as well? For first, you will need 0 and minus 1. Which is not, we do not have, minus 1 is not valid. So there are two base cases. One is n equal to 1 and the other is n equal to 0. So for n equal to 1, you guys already know the answer, it's 1. For 0, it's already 0. So for 1 plus 0 will be 1. You will get 1 here. 1 will get 1. 1 plus 1 will get 2 here. We don't know the second one yet. For 1, it's 1. For 0, it's 0. Addition 1. 2 and 1 is 3. And 1, 0. Let me change the color of the pen. Do you guys understand what's happening? I am writing the answers of the base cases and then I'm adding them and writing on their parent as well. 1 plus 0 is 1. For one answer is 1. For this will add up to 2. And finally we'll get answer 5. So check the series is the fifth Fibonacci number considering zero based indexing. Is it 5? Yes. This was third, this was fourth, and this was fifth. Fifth Fibonacci number is 5 because we are considering zero based indexing and not one based indexing. Any doubts until now? No? Right. Cool. Very good. Let's see how to write the code of it. Recursion work. What we want recursion to do? We want recursion to find the previous answer, or let's write it previous Fibonacci number. Previous Fibonacci number would be nth Fibonacci number of n minus 1 plus. Guys, don't get confused. I am writing code, but screen cover with black sheet. Can you guys not see my screen, or is it only with Rohit? Can you see code written on my screen? I'm writing some code on the screen. It's visible, Rohit. Probably your internet connection went down for a few seconds. What else do we need recursion to do? We want recursion to find the previous Fibonacci number as well. Basically, second last, n minus 2. What is our work? We have to find the final answer, and in final it is C++ Kamboji. Don't at all worry about the language. All right, just focus on that. I am finding this n minus 1th number, I'm finding n minus 2th number, and I'm adding them. If you understand this much, you're good to go. No worries. You have to. Can you not write the same code in Python by yourself or in Java? You of course can. So, okay, I wanted to write only pseudocode, but I thought for one question, let's write some code as well. Previous Fibonacci number plus previous Fibonacci number. And I need to return my final answer. We are yet to do one more thing. Can anybody tell me in the chat what is left in the code to do? I'm waiting. Like, you can look at the code and send your answers. Meanwhile, okay, Anupam gave the right answer. We have not found the base case yet. Right, let's do that then. Because if we don't write the base case, what will happen? We will run in an infinite loop and we'll get segmentation fault, runtime error. All right, just a second. I won't be able to run the code if I don't write these return statements. Right, so Dhanya has already answered that if n is 0, then return 0. If n is 1, then return 1. Right, these are our base cases. We have two base cases. All right, so this should work now, right? Let's see. Nth Fibonacci 8, and which Fibonacci we gave in the main. So 6th number we wanted, and yes, 6th Fibonacci is 8. So yes, the code is working fine. Do you want to see the stack diagram and trial run of this code now? Let's understand how it is working. If you have not, let's just tell me, guys, who did not understand how did this magic happen. I recommend to make the stack diagram for better understanding. If it is clear already, then we can move to the next question. But if it is not, let's surely do the stack diagram. Kamboji can understand. Okay. So a lot of people don't understand what happened. So do you guys understand from a higher level of view, like what happened? The current Fibonacci number is the sum of previous two Fibonacci numbers. We just made two recursive calls and added the previous answers and returned our final answer. That is what we did. Now let's understand this by doing a dry run. And while doing the dry run, I'll make the stack diagram as well. And it's okay if recursion feels like that. If in the beginning it feels like that, oh my, like how is it even happening? So that's okay if you feel like that. Some stack diagrams would definitely help you. You all can see the code here, right? So we have, let's say this is our stack, and the first, let's find Fibonacci of 4. Okay, so Fibonacci of 4 on this line. Now if you don't understand anything, ping in the chat at the same time, because if you continue listening and if you don't understand it, then by the end also you will not understand it and I'll have to repeat it all. So if you don't understand something, ping on the chat as soon as you see that, okay, this is something that I didn't understand. I'll repeat it as like at the same moment. Okay, we are on this line, Fibonacci 4. If n is 0, is n 0? What is the value of n, guys? For time being, Fibonacci 4's call is going on and n's value is of course 4. Is n 0? No. So no, we will not return 0. Is n 1? No. Continue moving in the code. Previous Fibonacci number is nth Fibonacci number of n minus 1. So there is this is the function call that is happening now. In this line, we are calling a function. We are calling the same function Fibonacci, but with what value? We are giving it the value 3 because n was 4. So if I give it the value 4 minus 1, it's 3. Now I will not move to the second line because in the stack there is a function call that is pending, right? So what will happen if I have called Fibonacci 3? What happens when you call a function? You start like you go on to the top of the function and then the function call continues. So at this line you are calling this function, so you'll go again on the top, right? Any doubts in this part? Like whenever this call is executed, you will go on the top again, right? Good. Okay, what is the value of n now? It's 3. Is n 3? 3, both of these will be skipped because it's 3. Now again I'll come on this line and I will try to calculate previous Fibonacci with nth Fibonacci of 3 minus 1. 3 minus, what is 3 minus 1 now? 2. So the next call in the stack will be Fibonacci of 2. We'll again go on the top of the function. These values don't match. Will again come on this line and Fibonacci of 1 will be called. Now when Fibonacci of 1 is called, n is 0. No, n is not 0. N is 1. Yes, n is 1. Now there is a return statement if the if condition satisfies. So Fibonacci of 1 will return. By returning, what it means? It means that it will give the control back to the previous call. It will return some value. Fibonacci 1 call has completed and it will return 1. So on this line, we will receive 1. So for Fibonacci of 1, we are receiving the answer as 1. Basically, for this call happened for n equal to 2 in the call of Fibonacci of 2, right? We were in the call of Fibonacci of 2 and we called previous Fibonacci equal to Fibonacci of 1. For Fibonacci of 1, the answer returned was 1. So for previous Fibonacci will become 1 now, right? So this will become 1. So previous Fibonacci value received is 1. Now for Fibonacci 2, Fibonacci 1, please say once from n equal to 4. Okay, so Rohit, the value of n in this particular call is 1, right? For n equal to 1, we returned 1 from this line. And this value was received by whom? This value was received by this function. And when was it received? It was received when n's value was 2. So Fibonacci of 2, let's focus on Fibonacci of 2. Fibonacci of 2, you called previous Fibonacci, Fibonacci of 1. You made a call to Fibonacci 1, which returned 1. So for Fibonacci of 2, inside the Fibonacci of 2 calls execution, you are receiving previous Fibonacci as 1. So this is received as 1 for n equal to 2. So the function call is completed. So we are for Fibonacci of 2 call. So this line executed, right? Now we can move to the next line. What is the next line? Next line involves calculating previous Fibonacci, which is this. What is previous? What will be passed now? N's value is 2, right? So 2 minus 2 is 0. So in the stack, this Fibonacci 1 was deleted. But now I have another function called, which is Fibonacci of 0. All right. Now I'll go on the top and n's value is 0. If n's value is 0, return 0. Yes, n's value is 0. So this will return 0 again. This will return 0 to Fibonacci of 2 function. On this line, okay, you got confused here, guys? Okay, let's do this again. Let me write it in a different way. Let me try to write it in a different way. So I'm starting from start. Fibonacci of 4. N is 0, n is 1. No, not true. So for Fibonacci of 4, I will call previous Fibonacci equal to Fibonacci of 3, right? Now for Fibonacci of 3, this code will be for Fibonacci of 3. Let me erase all of this. Okay, for Fibonacci of 3 again, you will see n is 0 or n is 1. So this is n's value. The value being passed to the function is n's value. So remember, here n is 4, here n is 3. You are on the top of the function. Is n 0? N is not 0, n is not 1. So again in this function, previous Fibonacci is Fibonacci of 2. Now we'll execute Fibonacci of 2. What do we do in the function call? From starting, we check if n is 1 or this is n's value now. N is 1 or 0? No, it's not. So what do we do then? Then we calculate previous Fibonacci. We move into the third line of the code. where Fibonacci of 1. All right. Now again calling Fibonacci of 1. What happens in Fibonacci of 1? When you call Fibonacci of 1, you hit the base case. N is actually equal to 1. So you actually return from Fibonacci of 1. Basically, you get a statement like return 1 when you call Fibonacci 1. And where will it be returned? It will be replaced from where it was called, right? It will be returned where it was called from. Understand this. Where will it be returned? Where will a function? It's a very simple thing. Where a function will return. To whom actually? To whom a function will return, or at what place it will return? It will return at whatever place it was called, right? And it was called at this particular place. So this will return 1 at this place. And see, where are we? We are at Fibonacci 2. Fibonacci 2 call was running. In Fibonacci 2, we got the value of previous Fibonacci as 1, right? Is it clear now? We have reached where we left last time. All right, Kamboja. Now the next line in the function call, if I go to the code, the next line in function call is calculating previous Fibonacci and passing n minus 2 as a argument. So previous Fibonacci is Fibonacci of n minus 2. Now tell me, what is n here? What is n here right now? Oh guys, it's not 1. It's 2, right? You are in Fibonacci of 2. Anupam gave the right answer. The argument will be 0, but n's value was 2. We are in the function call of Fibonacci 2, and n minus 2 will be 0. I think Anupam did understand it, but about others who gave the answer as 1, I'm still not sure what you guys were thinking. Is it not clear? Do you want me to try this, explaining this once again? To Kamboj, it's clear, and Anupam, I am sure it's clear. He gave the right answer. What about Rohit and Sargunan? Okay, I'm assuming it's clear now. We were in the function call of Fibonacci 2. This function, this particular line executed. So we move on to the next line. Now Fibonacci of 0 will be executed. What happens in Fibonacci of 0? It's a base case, you return 0, right? So you will have 0th value here itself. Now in the stack, basically I am drawing the stack calls in this manner now because you were not able to understand it in the stack. So I'm drawing it this way, whole cycles. Now we'll reach on this line, final answer, adding previous Fibonacci and previous Fibonacci. So for Fibonacci, again, we are still under Fibonacci of 2. And final answer is these two variables added, which is 1 plus 0. And what do we do now? We return. And remember, guys, I think your concepts about functions and how returns happen and how the return is given back to the function where from where it is called. It's not clear if you're not able to understand that if I return final answer's value is 1. Then that value is received by the function itself, right? So Fibonacci 2 value is calculated as 1 from this function. And where Fibonacci 2 was called, it was called under Fibonacci 3. So for this particular value, you are receiving 1 after it returned from the function call. Are you with me until now? Understood this part, that Fibonacci 2's value returned 1 was received in the function call of Fibonacci 3. I can see only Kamboj and Anupam saying yes to this. Does that mean others didn't? I think if you guys did not understand it, I will highly recommend you to watch the functions lesson again and see how the functions are actually executed, right? Okay. Now we will calculate. Now we can move forward to the next line. Okay, this call was executed. So we are free to move to the next line. This got a return, this got a value as 1. So now we can call previous Fibonacci as nth Fibonacci n minus 2. Now what is the value of n right now? In this particular function of n's value is 3, right? So previous Fibonacci will be Fibonacci of 3 minus 2, which is Fibonacci of 1. All right. Now Fibonacci of 1 will be called, which is a base case, so it directly returns 1, so you receive 1 here. Final answer will be addition of these two values, which is 1 plus 1, so return 2. So for Fibonacci of 3, you are receiving the answer as 2. So for Fibonacci of, basically, if I go by the stack diagram, whatever is being returned, whatever returns pops from the stack. the return statements that you have seen, at the same time, this particular function is popped back because its execution has completed. All right, now we can move to previous Fibonacci. Next line, we were on this line in Fibonacci of 4. We are back to the first function basically. Fibonacci of 4. In Fibonacci of 4, you called Fibonacci of 3. Fibonacci of 3 called Fibonacci of 2. Fibonacci of 2 called Fibonacci of 1. Fibonacci of 1 was a base case, so that was returned. So basically, something calls something, something calls something, something calls something. And this something finally reaches the base case and answers the call. This particular thing answers the call to this. So answer received. Again, answer sent back to the previous call. Answer sent back to the previous call. Basically, this is what is happening right now in recursion. And whenever answer is, this particular guy received the answer. So now this can move forward to doing, like, let's say this particular person wanted to call 3 people, but he called the first person. So until and unless he has not dropped the call with the first person, he cannot call the second person. If you can understand by that analogy, great. Right? I hope that makes it simpler to understand what's happening. You called one person. First, you will hang the call with the first person only, right? Then only you will be able to call the second person. Let's say this person but was speaking to some other person, and you are adamant that until and unless I speak to this person, I'll not call this person. But this person was, when you tried calling him, he or she called somebody else, right? I hope that makes a little sense now in layman language. So what will be this? Okay, tell me in the chat, what would be the argument here? What's n's value is 4 here and subtracting 2 from it, right? So Fibonacci of 2 will be called. And same thing would happen again. Fibonacci 2 is called and Fibonacci 2 will go again on the top, and Fibonacci 2 will call Fibonacci 1. Fibonacci 1 will receive answer as 1. It will return it to Fibonacci 2. Fibonacci 2 will receive. What's Fibonacci 2, by the way? It's 1 because it received 1, right? Yeah. So that is also received. Now you can move to the other next line, which is 2 plus 1, which makes it 3. So now you return 3. And Fibonacci 4 was the last call. It's the only call in the stack, which was the final call. And we receive the answer as 3. And 3 is our answer. This was the final call that wanted to complete. After Fibonacci 4, there is no call except the main call in the stack. Okay, we took a lot of time in one question itself. I was not expecting that at all, but I wanted to also make sure that you guys understand it properly. Okay, do any doubts in this question now? And we have read to add previous Fibonacci and previous. Yes, Rohit, great. Let's move to the next question, and I hope you have a lot more clarity about how function calls work now and how recursion is calculating the previous answers. Next question is reverse string. All right, I am given a string. Let's say, let me write the name of Anupam itself. So let's say this is Anupam's name, string. This is given as a string. So the question asks that you have to reverse. Basically, if this is the input, then in output, I should get MAPUNA. Rohit, when Fibonacci 3, the result is 2. Yeah, 0, 1, 1, 2. So this was 0th Fibonacci, this was first, this was second, and this was third. Yes, for third Fibonacci, the result is 2. Given string, Ishan is asking, so we took base case from 0, not 1. Yes, Ishan, we took both base cases 0 and 1, because if we had not had 1 as the base case, then 1 would call 0 and minus 1. And minus 1 is not a value, all right? So even before I asked, I have an answer. Chand, I'm not able to read the full name because it's not visible. Chand Patel. Given string so that the last character of the string becomes the first character of the string. Yes, basically that is the question. Now, how can I solve it? Let's see. Any approaches that you guys can think of, or let's not waste time in that. I will directly share. Okay. So I wanted to reverse Anupam. And what did reversing it mean? It meant that I will swap all the characters like that. Reversing means swapping characters, right? So A would become M and M would become A. In place of N, A would come. In place of A, N would come, right? That is what is meant by reversing. So see, what do we have to do? First thing, we have to find a smaller one. Basically, ask recursion to do something. In this case, what can we ask recursion to do so that we can find a final answer by ourselves by doing some work by ourselves? If you notice clearly, let's say I said that, okay, it means reversing string. So what I'll do, I'll just reverse the first and the last character, and I'll ask recursion. Let's talk about that, Sargunan, a little later, if the string length is odd. Let's consider this example for now. Okay, so what if I reverse? What I'm doing is I'm asking what I'm asking recursion to do is he do go and reverse NUPA for me. And what I will do, whatever you return for me, what will a recursion return to it? Let's say that if I ask recursion to reverse NUPA, what result will it give to me? Answers in the chat. If I ask recursion to reverse NUPA, what will it return? APUN, right? Now I'm saying, okay, you return something. What I am gonna do is, I'm gonna swap the first and the last characters. So initially, here I had A and I had M. I myself will do, in place of A, I'll write M, and in place of M, I'll write MAPUN, Mapuna. So, right? So I asked recursion to solve a smaller problem for me, and I solved one simple problem by myself. We cannot again remember ask recursion to do all the work for us. That we will be again on the top of the question. If we ask recursion to solve Anupama, that is the question, right? So, all right. So that is, do you guys see the approach now? What are we doing? Let's take an example of an odd word. Let's say Rohit, 3, 4, 5. Now I'll ask recursion to reverse this for me. What will recursion return from this part? It will return I, H, O. And what will I do? I will reverse the first and the first and the last letters. So I'll write T here and I'll write R here. That is all. Base. Okay. How can we do it programmatically? Let's think that way. We know the smaller problem is like leave the first and the last character, and whatever is in between, ask recursion to return the answer for that. So let's call it mid string. So what I'm doing is, what is my small answer? Let's say the string str is Rohit, and so what I want recursion to do, I'm calling the function as f, okay, or let me call the function as reverse. What I'm going to ask recursion to do, recursion, please reverse OHI for me. And whatever small answer you will return, what I will do is I will how will I make my final answer? I will just swap the first and the last character of the original string. That is what I will do. In the original string, I will swap R and T. So basically that would have made my answer. Basically you will pass not only OHI to it, you will pass Rohit to it. But in Rohit, we are asking it to work on OHI only, right? So this would return R, I, H, O and T. And what I will do, there is only one problem. Rest of the part is solved. There is only one problem. R and T were not swapped. And in this step, I swap R and T as well. So this will become TIHOR. Now, how can we achieve it? So there is a catch here. The catch is we want to pass the whole string, but we want recursion to work only on the middle part of it. So let's see how can we do that. Let's say this is our main function, void. I'm not writing the return types as well. This is pseudocode. You can convert it to any language. Reverse string. This is the function. And you pass it a string, and let's call it the string as str, right? We need a helper function actually here. And I'll tell you why we need a helper function. So the helper function, see what I'm going to pass. I will pass the string, I will pass 0, and I will pass strings size -1. What does this represent? This represents, let's say, start or an end of the string, or you can call it low and high as well. What will happen in this helper function? Be patient, you'll understand what's happening. String, and let's call it low and high, or let's call it start or end. And this is receiving it by reference. This is also a void call. What I'm expecting, so see, now you remember what was the problem statement, like when we were discussing from here. We were having the string as Rohit, but we wanted recursion to work only on this part of it. So this low and high represents that this is initially I've given low as 0 and 0, if I index it, 0, 1, 2, 3 or 4. What I want recursion to work on, initially, what is the problem? We initial problem is to reverse the string 0 to 4. What I'm asking recursion to do is to reverse 1 to 3, and that is why I needed those two extra parameters in the helper function. Do you guys understand this part now? Why I have taken start and end? Because the original problem was to solve 0 to 4, but I want recursion to solve 1 to 3. If not, you will understand it in a driver. So helper is the main function that will solve our problem. In helper, what we'll do? What shall we pass to helper start and ends value? This is the recursive call, okay? What do we want? Start was received as 0, end was received as 4. What do we want recursion to work on? We want recursion to work on the string just after leaving the first and the last character. So I want to leave the first character, I want to leave the last character. On the remaining part of the string, I want recursion to work. So I want to pass 1 and 3 to it. Like if you take the example from Rohit, OHI represents 1, 2, 3. And that makes sense, leaving the first and the last only. So basically this would be start plus 1 and this would be end minus 1. 0 plus 1, 4 minus 1. That is what we want. And what we want to do by ourselves, we want to swap in this particular, we are assuming what this particular call will do. If I pass Rohit as a string with 0 and 4, this particular recursive call will convert Rohit to RIHOT. All right. Again, smaller work. Don't think a lot about it. Just assume that recursion is doing your work. If from the PPT, if you remember that we did in the first session, you have to take the recursive leap of faith, trust recursion, that the recursion is gonna give me the right answer. Okay, so this will convert Rohit to RIHOT. Now our work is still pending. What is, and how will I reach my final answer from RIHOT? What is my final answer to here? My answer is TIHOR. But what I have is, I have RIHOT. So what do I need to get the final answer? I need to swap the first and the second letters. Swap string of 0 and string of 4. Okay, that is what you want here. Or which is also start and high if I write the start and end if I write in the terms of variable. That is all. This is the recursive work. This is your work. Now base case. Let's talk about base case. What is the smallest problem that you think you know the answer for sure? Let's say if I give you a string of only one letter, if I give you T, if I give you P or any other alphabet at all, this is the base case because the answer for A is gonna be A for answer, P is gonna be P. So basically strings of length 1 is our base case. Now, shall we write string of, if string of length of string is 1, then return the string itself? No. In every function call, the string being passed is Rohit only. The string being passed is not changed. How are we determining the change? We are determining the change by these two variables start and end. So let's say if for Rohit, start and end would be 0 and 4, and they will be converted to 1 and 3. So, and this will be converted to 2 and 2. So ultimately when low and high has become equal, or basically start and end has become equal, it means that you have reached a point when low's value has become equal to high. So if low's value becomes greater than or equal to high, it means you have to return now. You have reached a point that you don't need to do anything at all. Okay, so our base case would look like if start is greater than equal to end, then you return. You don't do anything. That is the base case. Okay, so from high level, don't think about, if you trust this line, if you have trust on this particular line, if I say that you trust this line, how many of you understood the approach of the question? After assuming that you have trusted it, don't worry about how it might be happening inside the stack or inside the dry run, just the approach. Is the approach clear? Okay, all right. So do you want to see the dry run and stack diagram of it? and see, like we have last 4 to 5 minutes of the session remaining. We can utilize them either to do a new fresh question, or we can do a dry run of the same question. You guys tell me what you want. Dry run it? Let's do the dry run. Where can I get the previous class? Kamboj, Ajay, please send the link of the previous class in the chat once this session is over. Shan, sure. It's dry run, by the way. It's not dry run. In programming, that is called as a dry run. Dry run means running over the function. Raw. Okay. So how my function looks like? Let me very quickly write it, and I have the function parameters already passed, so I just need 3 lines here. So I'll quickly write it as well. S, and what we decided, low plus 1 and high minus 1 will be passed in the recursive call. And what is our work? We wanted to swap strings first and the last character. So original string was desire, and reverse string came out to be erased, which was what was expected. Okay, let me take this code to the whiteboard. And after the dry run of this particular code, the session will end, but Ajay has an announcement to make. Ajay, do you want to make the announcement right now before I do the dry run? Because people might want to leave.
Sorry, Manvi.
Do you want to make the announcement right now, because it's already 8? People might want to leave.
Okay, cool. So 2 announcements, guys. That is one thing gonna be on Manvi's next upcoming class, that will be on backtracking, and it would be on 18th. And one more thing gonna be, you'll be having a session tomorrow that would be an Insta Live podcast from Pratimesh Joshi from CRED, and I would be the moderator. It would be related to blockchain and Bitcoin related things. I believe you can definitely get most of the things benefited out of, and you can bring back your friends or else whoever is interested to know more about Bitcoin and blockchain thing. Okay, so those are the things that you can stay tuned to. Yep, that's all.
All right, we'll also end the session just by doing the dry run of this question.
Sure, man.
Also, guys, the next session by me is gonna be on backtracking, and recursion is the base of backtracking. When is the next session, Ajay? It's a little late, right? Or is
It's
it
on 18th.
Okay, it's on 18th. Guys, it's 11th already. You will have to be good at recursion to understand backtracking sessions. Not more than that, like whatever is taught in the this session and the previous session. If you do those 2 sessions, you can come to the backtracking session. Also, please try some more recursion questions. Recursion is not something that you will excel at just by solving 2, 3, 5 questions. You will need to solve a lot of questions, and you will do a lot of work by yourself as well. How to write program on our, let's take that question after I do the dry run. Let's just quickly do the dry run of this question, and then we'll do discuss a couple of things that are in the Q&A. Okay, so I will make Rohit explain it, code on which you copied. Yeah, I did explain, like that was the base case, and this was the recursive call, and this is my work. All right, let's do it then. I will make the stack diagram this time, as well as the the recursive calls the way I made it in Fibonacci, so that we understand it very clearly. The first call is reverse string. I'm not writing the name of the whole function. I'm just calling it as rev, reverse. So in reverse, I'm passing Rohit. Okay, so reverse Rohit. And what is 0, low and high? It's 0 and 4. 0 represents R, like the indexing wise, and 4 represents T. Okay. If low is greater than equal to high, this is low and this is high. Low is not greater than high. Low is lower than high. So we're good. We are not hitting the base case. Now, in the next line, this is the first, let's call it first line. This is second line, and this is line number 3. Okay, and this is the function call. We are on line number 2. On line number 2, we call reverse of Rohit again. This is Rohit. I did not change the string, but what did I change was the low and high values that I'm passing. Low is increased by 1, so 0 becomes 1, and high is high minus 1. So 4 minus 1 is 3. Again, I'm on line number 2. But I make a function call here. So I cannot go to line number 3 until and unless the function call on line number 2 returns. So this function calls this function. This is Rohit 1 and 3. We go on top of the function. If we go on line 1 once again, line 1 has the base case, but it is not hit because 1 is not greater than 3. 1 is not greater than equal to 3. So we come on line number 2 again. On line number 2, I make another function call, which is string is still Rohit. Don't change, no change there. Low is increased by 1. What was the previous low? This is the previous low. This function call is being executed. Remember that. The previous low was 1. So we increase 1 by 1, which means it becomes 2. And decrease high by 1, 3 minus 1 becomes 2. So this particular function makes reverse Rohit and 2 and 2. And what are these numbers representing? Once again, starting from the first function call, what are these numbers representing? This represents 0 and 4 represents that I am asking this function to reverse the string start from 0 to 4. I want the answer from 0 to 4. 1 to 3 represents that I want to reverse only OHI. Okay. 2 and 2 represents that I only want to reverse the second index, which is H. Okay. Now I am again on line number 1. For line number 1 this time, in this case, line number 1, the if condition comes out to be true because low is 2 and high is also 2. Low is greater than equal to high. So we have hit the base condition. And if we hit the base condition, what do? We return, right? So this function call actually returns and nothing happens, right? Nothing happens. And where is this call returned? Where was it called? Like this particular call pops out from the stack. So the stack doesn't have this function anymore. It has been popped out because it reached a return statement. Whenever a function returns a reach statement, it's popped out of the stack. If you can understand it that way. Where do we go back? We go back on line number 2, basically, right? If this was returned, this was called from this function, right? If you see it from the stack or you see it from here, both the things are same. Just a second. Now in line number, for this particular call, line number 2 executed. This particular thing, 1 and 3, this particular call executed. Line number 2 executed for this call. After line number 2, I will go on line number 3. And what I'm doing on what did line number 2 did? It did nothing. It just returned. Nothing happened on line number 2. But no other function call was also made. So basically, we can move from line number 2 to line number 3 now. What are we doing on line number 3? We are swapping the first and the last character of the string. That is, basically, what are we swapping? Are we swapping the first and last? We are swapping low and high. And what is low and high right now? Low is 1 and high is 3. It's not 0 and 4. We are in the Rohit 1-3 call, right? We are executing the Rohit 1-3 call. Rohit 1-3 call. For Rohit 1-3 call, low is 1 and high is 3, right? And let's say in the original string Rohit 0, 1, 2, 3, 4. What is on first index and what is on third index? This is swapped. So P and O swaps. Okay. So what will the string become after executing line number 3? The string will become R. R will remain at its place, but on one index, it was originally O, but I have swapped O with T. So I will get R, T, H, O, and T. Or this is I, this is not T. These two values were swapped. So Rohit became R-I-H-O-T. All right. On line number 3, Rohit became R-I-H-O-T. I hope it's unclear until now. On line number, after line number 3, there is nothing. There is the function call. The function basically completes. And when there is a closing bracket also means return from the function. Okay. So I could have returned actually explicitly also I could have returned here. But if it is, even if it's return, not return here, it means that the function call is returned. So for reverse Rohit 1, 2, 3 call, you are receiving the answer as R-I-H-O-T. And wasn't that the correct answer for this particular call? We wanted to reverse 1 to 3 and 1 to 3 is reversed, right? So this particular function call also completes. So it is popped off the stack, basically popping it from here, popped off the stack. Now the control is given back to the Rohit, 0 to 4 call. Okay, so this is 0 and this is 4. We were on line number 2 of this. We are on the original call now. This was line number 4. Line number 2. This was line number 2. Okay, so line number 2 completed. And what did line number 2 did? Line number changed Rohit to RIHOT. It reversed 0, it reversed 1 to 3. This was 1 to 3. So it reversed OHI to IHO, right? Ishan, the answer that you have written is the final answer. That will be done in the line number 3 now. Now we reach the line number 3 and we are swapping the low and high. Now what are low and high right now? Low and high now are 0 and 4 because we are the function, we are executing the 0 and 4th call. How does the string look like right now? String look like this right now. And in this you are swapping 0 and 4. Basically this becomes T and this becomes R. And after line number 3 there is a closing bracket, which means this function calls also returns, and it will return to the function from where it was called, like basically the original main function in case of C or C++ or Python as well as a main function. So we gave the input to this function as Rohit, but final answer that we have received is TIHOR. All right, that's how the dry run of this particular code looked like. So basically, guys, don't get confused. Like, how will you think so much? If you have noticed until now, smaller problems are actually solved first. You write it in a way, if you dry run, you will realize the obviously smaller problems mean base case. Base case solves first, which gives answer to smaller problems, which gives answer to bigger problems. So don't think about the dry run when you are thinking of the logic. Do the dry run few times, like if you are a beginner in recursion, to understand how things are working. But when you have understood like how things are working, how function control is being given from one call to the other, then there is no need to dry run. And even when you are thinking of the logic to write a particular code, no need to think about so many things, right? If you do a dry run, there are so many things, so many stack calls happening. You don't need to think that much. You just need to think 3 points. What should I ask recursion to do? Ask recursion to do something, do some your work, and think of a base case. That's all. But also having an understanding of how it works behind the scenes, that you will understand if you yourself dry run the code few times. All right. That's all, guys. That's all from my end today. Any questions you have? I hope it is clear, and I am gonna, in the assignment, I am expecting you guys to solve the questions from the current session and previous session. And because not many people did the previous assignment as well. So I'll still ask Ajay to send them once again and try to solve all of these questions, at least, if not more than that, right? And next session we'll be doing backtracking. We'll be starting with backtracking. So I hope in the current 1 week you will get an understanding of backtracking, recursion, I mean. All right, guys.
Okay, great. I think, guys, I believe you have received a mail regarding the previous session's assignment. You can once take a look in that, and you can check our LMS platform also, learn.verzeo.in. You have Manvi's previous video, which is already posted there, and you will be able to find the assignments over there also. Okay, and for the 18th class, that is on backtracking, you will get a mail tomorrow. You can stay tuned, check your emails properly. Okay, and we do promotions in social media handles, that is Instagram and LinkedIn. You can check out the the sessions, the webinars, whenever it's gonna be happening. So if you haven't received a mail, or else if you are not able to find the mail, you can just check out the link in our LinkedIn handles. You will be able to find that. And as I've told you, for tomorrow's link that is held in Instagram Live, that is a new thing that we would be going ahead with. I have shared you the link over here. You can check it out and you can register yourself over there. Just you need to be present and you can ask your doubts related to cryptocurrency world, whatever doubts you have, new technologies that you want to learn about, anything it would be. Okay, that would be a free session that you would be attending, and you can get your friends, family members, or anyone who is interested to learn more about cryptocurrency. Okay, so that would be the thing on tomorrow's session, and this recording will be uploaded in your portal, I think, in 2 days. And I'll share you the LMS link also, guys. Learn.verzeo.in. So this is the link. You might be a learner from Verzeo, or else you might be a new joinee, or else you have saw the ad, or else you might have come through the social medias. You can sign up yourself over here, and there is a premium webinar which is kept free, and you can go through it, and you will be able to find uh, the previous recordings, the current recordings, and everything. Okay, and I think that would be the thing. Manvi, do you have anything else to mention? I think Rohit has something to ask.
I cannot understand what he's asking. He's probably asking for the mic to ask out. It's difficult to type in chat.
Rohit, if you have any questions, you can just elaborate on it. I think she'll be here for a minute.
Though I would like to answer Dhanya's question. Meanwhile, she asked how to solve questions on our own rather than memorizing. So Dhanya, like, understand the concept, understand the basic concept of recursion, what it is and how it works, and then practice as many questions as you can. Like, there is no other formula of being able to solve questions by ourselves than by practicing to do by them our own. Rohit, ma'am, in a string we have first, reverse, I and O. Yes, that was the smaller problem. So for Rohit, which was the base case, so you did not do anything with H. After H, 2 and 2, H remains. 1 and 3, I and O swaps. After 1 and 3 swaps, it will become OHI instead of IHO. And that would make the string as RIHOT. And that would, after that call returns, R and T would be swapped.
Okay.
How R and T?
Yeah,
Do the dry run, Rohit. Try to do the dry run by yourself once. It's the same as Fibonacci. You just have to return at the right place and continue from the right place. Then after 2 and 2, H remains same. You are also writing the right answer in the chat and then also asking how it's happening. 2 and 2 remains same. 1 and 3 swaps, and then 0 and 4 swaps. That's how it works from here to here.
Okay, great. I believe we are just running out of time. That's all for today. And guys, you can stay tuned for Manvi's upcoming session on 18th. And whatever the doubts that you would be having, I would strongly recommend to bring back your friends also who have joined previously, or else who are eager to see Manvi working on backtracking. That would be the thing. Thank you so much, Manvi, for sparing time and sharing the knowledge with the candidates. Yep, that's all. Thank you so much, one and all. Have a great evening. Bye-bye.
Thank you, Ajay, and thanks everyone.
Thank you so much.
Thank you. Visit Verzeo.com, subscribe to our channel to know more.